Yes, this is 300 plus academy, where all we do is exams, tutoring. Yes, still on the subject matter, chemistry alternative to practical, GCE. We bring to you another probable question for your chemistry alternative to practical. Of course, looking at what you have on your screen, it says A is dilute H2SO4. A is dilute H2SO4, and B is 1.50 gram sodium hydroxide, 1.50 gram sodium hydroxide, 1.50 gram sodium hydroxide per 250 cm cube solution, per 250 cm cube solution. Okay, what do they want in this question? Concentration of B in mole per dm cube. Okay, the very first question they want on A1 is concentration of B in mole per dm cube. I cannot overemphasize this. You're looking at mass here, you're looking at volume here. Concentration in mole per dm cube, of course, is mole divided by volume in dm cube. So that what you have here, mole is mass over molar mass, and then because the volume is in cm cube, you have volume in cm cube times 1,000 comes up here, so that what I have for this, what is my mass? My mass is 1.50 times 1,000 divided by 250. Because I'm doing sodium hydroxide, if you calculate sodium hydroxide, NaOH, sodium is 23, oxygen is 16, hydrogen is 1, that gives you 40. So if you compute this, the concentration of B in mole per dm cube is actually, if you compute from your calculator, that is 0.15 mole per dm cube. 0.15 mole per dm cube. So that ends question A1. Question A2 says calculate the concentration of A in mole per dm cube. Ca. A2 says Ca in mole per dm cube. That's the question. Of course, I wasn't given any information about my A, so that makes my A a solution that is not standard. Of course, talking about my B, it is standard because I now know the concentration. So that's Ca. In the question, yes, I was given the equation. So my Na, which talks about sulfuric acid, is 1, and my Va, looking at the information at the start, the volume of my acid is 15.5 cm cube. 15.5 cm cube. That's what is required for complete neutralization of the sodium hydroxide. Of course, Cb is 0.15 mole per dm cube. My Nb, as seen from the equation, is actually 2, and my Vb is the volume of the pipette, which is given as 25 here. So Ca Va over Cb Vb equals to Na over Nb. My Ca, if I make that the subject, is going to be Cb Vb Na divided by Va Nb, and Cb here is going to be 0.15 times Vb is 25, Na is 1 divided by Va 15.5, Nb is 2. If you compute this, my Ca, concentration of my acid, if you compute from your calculator, is 0.121 mole per dm cube. Okay, that ends question A2. Moving on to question A3. Question A3 states number of hydrogen ions in 1 dm cube of solution A. Number of hydrogen ions. I'm looking for the number of hydrogen ions. Okay, But if you look at it, the hydrogen ion is definitely going to come from the sulfuric acid. My sulfuric acid here is H2SO4, and if I dissociate this, this is going to be 2H plus SO4 2 minus. Talking stoichiometry, there we go again. This is 1 mole, this is 2 mole. So we know that 1 mole of my H2SO4 is equivalent to 2 mole of the hydrogen ion. So if I say 1 over 2, 1 to 2, then what is the concentration of the H2SO4 we are just calculated? That is going to be okay, that is going to be the concentration of the H2SO4 is 0.121 mole dm. So if I'm saying 1 to 2, that of course 0.121 mole per dm cube means 0.121 mole in 1 dm cube, and I'm looking for the number of hydrogen ions in 1 dm cube as well. So that means 1 to 2 is same as saying 0.121 mole divided by the mole of the hydrogen ion. Taking note that this is in 1 dm cube, and I'm looking for the number of hydrogen ions in 1 dm cube as well. So the mole of my hydrogen ion is going to be 2 times 0.121 mole, and this here, if I compute that, is going to give me 0.121 times 2. That's going to give me 0.242 mole. 0.242 mole. So having 0.242 mole as my mole of hydrogen ion, remember what I'm looking for is number of hydrogen ion. So number of hydrogen ion, number of ion is always mole times Avogadro's number. If you look at it, for the Avogadro's number, we've been given 6.0 times 10 raised to power 23. So if we deal with this by saying, okay, 0.242 times 6.0 times 10 raised to power 23, if I compute this, what I'm going to have is 1.46. Yes, 1.46 times 10 raised to power 23 ions. So that is my number of hydrogen ion. That way I've been able to answer A Roman figure 1 for 4 marks, A Roman figure 2 for 4 marks, A Roman figure 3 for 4 marks. That ends that. Now I am moving to A Roman figure 4, where what they want is volume of distilled water that should be added to 25 cm cube of solution. Yes, A Roman figure 4 states volume of distilled water that should be added to 25 cm cube of solution A in order to dilute it 10 times. Okay. So what this means is that V1 is 25 cm cube. Of course, for the concentration of A is actually 0.121 mole per dm cube. So we are looking at how much water do we need to add to this, plus how much water do we need to add such that the concentration now, the milk. So this Ca now is my C1. This is my C1. Recall that in one of the content I talked about dilution law, where I said C1 V1 equals to C2 V2. Of course, what this means here is that if I want to dilute this 10 times, that will mean my C2 is now going to be 0.121 divided by 10, and that gives you 0.0121 mole per dm cube. Of course, dealing with this is now going, if I use C1 V1 equals to C2 V2, so my C1 is 0.121 times C1 V1, 0.121 times 25 equals to 0.0121 times what will be the new volume. That's what I'm dealing with here is C2 V2. C1 V1. So my V2 is going to be 0.121 times 25 divided by 0.0121. So my answer here should give me 250. Yes, this is giving me 250 cm cube. So if my V2 is 250, so what should have been added? What should be added is V2 minus V1, and that's 250 take away 25, that is 225 cm cube. So that is what should be 225. That is what should be added. So that ends A4, and that is also for 3 marks. So that ends the whole of question A. Moving on to question B. Question B says, what will be the color of methyl orange indicator in solution A? What will be the color of methyl orange indicator in solution A? Methyl orange in solution A. Of course, our solution A here is H2SO4. So what is the color of methyl orange in an acid? What is the color of methyl orange in an acid? That is pink. That is pink. Methyl orange in an acid is pink. What will be the color in solution B? Solution B, according to this question, is sodium hydroxide. Okay, that should be yellow. And of course, I was told what is going to be the color in a titration mixture of A and B at the end point. At the end point, that is, of course, neutral. That is going to be orange. Okay, that is talking about indicators. Of course, in one of our contents, we'd already explained about indicators. So with that, we've been able to attempt this probable question, and that just ends that. Do not forget, like, comment, subscribe, and turn on the notification bell so that at every time we upload sumptuous content for you, you can get notified, and of course load your brain with that. So with that, we've come to the end. From me